Hi all, good morning. In today's lecture, we'll be talking about the correlation coefficient between marks of 10 students of two different subjects, computer graphics and machine learning. So here is the data which is given for two different subjects. There are 10 marks and the value of n is 10. Okay. Now let us calculate the mean of x and mean of y. We just name computer graphics as x and machine learning as y. So we'll find the mean of x and the mean of y. That means you just take the total of x and divide by number of terms here. Okay, so that is 32, and also you divide, take the total of y and divide by number of values, that is 30. So you get the mean of x and mean of y. Okay, now we'll make a table. So here is a table which is going to just help us to form the correlation coefficient. We are going to find it. So we have our x and y. Okay, so the last row just denotes the sum of the columns of all this. Okay, so just ignore the last row because it is talking about the total. Okay, now since we have large values here, so we just transform this x and y columns into smaller values. So how will we do it? We'll just take the mean of x and mean of y, we'll use in this columns. Okay, so I'll just subtract the mean of x from x and subtract the mean of y from y. That we'll call it as u and v. Okay, so we have two new columns which has been just formed from x and y. So our x and y data has been transformed to a smaller value. Now let us find u and v. Just multiply this u and v column, so we'll get this column, and just find the square of u, that will be u square. Find the square of v, that will be v square. Just sum it up. Okay, so the summation is just written in the last row. Okay, now let us use the correlation coefficient formula: n into summation xy minus summation x summation y by square root of n into summation x square minus summation x whole square into square root of n into summation y square minus summation y whole square. Now this will be transformed to u and v because we have just transformed x and y to u and v. So we have n into summation uv minus summation u summation v by square root of n into summation u square minus summation u whole square into square root of n into summation v square minus summation v whole square. Okay, so we just transformed this x and y in terms of u and v. Now just try to substitute these values, like n is 10, summation u is here just minus 93, summation u summation v is 0, and square root of n is 10, summation u square is this 140 minus summation u is 0 square into square root of n is 10, summation v square is 398 minus summation v is this 0 square. Okay, so once you compute this answer, you will be getting minus 0.3939. Okay, so it is an approximate value. Okay, so this is your answer, and this is talking about the negative correlation. Okay, let us see a picture where this correlation of x and y is plotted in a scatter matrix. Okay, scatter diagram. So you can see this scatter diagram. So this is talking about the negative correlation. Okay, and the data is just scattered. So some data is just lying distant apart from this, this negative pattern. So the strength is very low here. It is minus 0.39. Okay, so this is the representation of the data in a scatter diagram. And this confidence interval, this is talking about the correlation coefficient which is lying in between this. Okay, this we will study in the later part in test of hypothesis. Okay, so that is the concept behind this correlation coefficient. Thank you.